Hi, I'm Professor Paul Poxtelis, and today I'm going to be telling you a little bit about these 3D printed amino acid kits that are for use in Biochemistry 461 at the University of Maryland. Now, the goal of these kits is to give you a better appreciation of amino acid monomers, how they assemble into polymers, and some of the structural implications for peptides and proteins down the line. In this video, I'll describe the contents of the kits, I'll show you how to prepare them, and give you some of the basic instructions on how to put them together. There are a number of different components in each kit. There is enough in each kit to make a tripeptide. So in this case, there are 3 alpha carbons that look something like this. So here's 1, 2, and 3 alpha carbons. There are 2 peptide linkages, which you also can just call omega pieces here. There's 1 each of a carboxyl group and an amino group, and 3 of these black spheres, which are R groups. If I hold this just right, you can see that there is an R on there. And 1 of these, which could be in a variety of different colors, this is a torsion angle estimator, and that'll be described in a later video. Now, before we can actually use some of these components, we have to remove the support structures that are associated with them. Because 3D printing is an additive manufacturing technique, you can't print things in midair, so you need to have support structures underneath. Now, the easiest way to do this is to use a tool, in this case, some needle nose pliers. Really, any pair of pliers will work, and even in a pinch, something like fingernail clippers or something like that, anything that you can grab onto the support structures will allow this to work. In fact, with a lot of these models, you don't need anything at all. You could just use your fingers and pull them off. But I'm going to show you first how to just remove this from the alpha carbons here. Okay, now that we're zoomed in here, you can see all I have to do is really grab some of the support structure and hold the model at the same time and just start pulling away at the support structure. And you can see really that was quite easy. It didn't take a lot of effort to remove that support structure. And some of these, I can easily just do this with my fingers. You can see this comes off without much difficulty at all. And we have our alpha carbons here. Some of the other ones might be a little bit more difficult. Here, for example, is this omega or peptide linkage that we have here. And you can see I can kind of wedge my fingers in there and get it off, but this is going to be made easier using these needle nose pliers to remove the support structures. And just be careful here. Don't pinch your fingers. Don't get them stuck within the pliers in any way. You'll be all right. The main thing you want to watch out for is not trying to put too much force on the model when you're removing the support structures. Now, for these things that are left over, all of these models are printed in PLA plastic, which is somewhat biodegradable, so you can feel okay about throwing them in the trash. But if you prefer to recycle, hold on to these, and you can bring this to 3217 in the chemistry building, and I have a recycling bin there for this specific type of plastic. You're going to want to go through and go ahead and do this for all of your models that you have. Remove all of the support structures, and they'll come off fairly easily, hopefully. Now, you may run into some situations when you're doing this where you'll actually have a little bit of the model will get removed with the support structure. As long as it doesn't disrupt any of the holes in the model, for example, we have a hole on either side of this one, then it's fine. You may also end up cases where there's little bits of the support structure left over. Because these are your models to keep, you can remove and clean them up as much as you'd like. So in this case, I'm trying to get a little bit more of that support structure off. And here is the carboxyl group. You just essentially do this the exact same way in removing the support structures. And this is one you can see is a little bit more difficult to get off. I'm having to use the pliers just a little bit more to remove it. But without too much difficulty, the supports are now off of this as well. And this amino group should be fairly straightforward. It just has a small support structure to take off. Unfortunately, there are none on the R groups, so you don't have to worry about those at all. All right, now, once we clear all this stuff up, get rid of all of these old support structures, we can begin looking at how we can actually assemble these amino acid pieces into first amino acids and then peptides. One of the unique things about these models is that they have these splits in each of the bonds. This allows you to add components at one position and take them off and make different assemblies using just the same sets of components that we have here. What I'm going to tell you about now is just on how to put these things together, just as a sort of a warning for things you should look out for and the appropriate method for putting any of the different substituent groups in place. So for example, for this alpha carbon, we've intentionally made one of these bonds a little shorter, and this is for the amino group. This is just to give you a placeholder. If you'll notice, this one's just a little bit shorter than these others. So if we take our amino group here and we begin putting it on, you can see it doesn't fit in all the way. And if we were to just squeeze really hard, this would go on. But a safer way to do this is actually to just sort of twist this on. So as you push, you're going to twist this on, and then you can feel that, you'll feel when it actually clicks into place. And now you can actually rotate this around a little bit. And after you do this the first time, it'll become a lot easier. So now if we use a little bit of force here, we can pull this off. And now that we've cleaned up this bond a little bit, and we can just push it into place. And you probably even could hear that audible snap as that went into place here. Now we can add the other components as well. So in this case, I'll add the carboxyl group here. And in the same way, I'm going to just kind of twist this as I put it on the first time, and you'll see it goes on quite nicely. And then we can take one of our R groups and put this on, and again, twisting it into place as we push. You're going to need a little bit of force. The main thing that you want to do is make sure that as you're twisting, you're pushing straight onto the bond. If you push to the side, you'll snap that bond off. Okay? So just keep an eye out for that. And now in this case, we have an L amino acid. And now you can actually ask yourself, how would we actually go about making a D amino acid from this component? So this is an individual amino acid with this R representing our side chain in this case. We have our amino group and our carboxyl group. So how would we go about putting these together then? Well, as you guys will either have already working on or you will be working on, if we remove this carboxyl group here, we can bring in this next linkage. So this is what I called the omega group, or the peptide linkage. So what this effectively does is, this is now our carbonyl, and this is the amino group from the next amino acid. So we can see it's the carbonyl, we've got the keto here, and now this is the amino group from the next amino acid. So we can simply now push this together. Here's our new amino group that we have on here. So we're going to make sure that we use our shorter pin. Let me get that centered a little bit more. We're going to use our shorter pin here on our next alpha carbon, and we're just going to twist this on, making sure that we twist it on straight. And now we have our second amino acid going into place. If we're making a dipeptide here, we have our carboxyl group that can go on, and then we have our R group that can go on. And we have now a dipeptide. And you can see we have rotation in this dipeptide. And this is what's going to be important for some of the structural characteristics of peptides and ultimately proteins. Now, one of the things that you'll notice is that we've given you these amino groups and these carboxyl groups in blue because this is positively charged at neutral pH, and this carboxyl group would be negatively charged at neutral pH. But all the other atoms in here are just a single color, and this has to do with how easy it is to 3D print things in different colors. One thing that, because these are your models, that you're quite capable of doing, if you'd like to, would be to actually come through and paint these models. So standard colors would be carbons and black. So just using even cheap acrylic paints or nail polish will also work, though the cheap acrylic paints will actually give you a better result. You can paint the individual atoms as you'd like, and here, for example, is one of these omega groups where the nitrogens have been painted in blue and the oxygens have been painted in red, and we can assemble these things together. As you can see here, here's our next carboxyl group going in, and you don't have to paint all of these. You could, for example, if you just wanted to leave the alpha carbons one color, or just leave the carbons altogether in the peach color, that would be fine as well. This is just, if you want to do this, to help you recognize what atom is what in these assemblies. I hope this video was instructive in helping you put together your 3D printed amino acid kits, and I hope that these physical models will help you appreciate amino acids and how they are assembled into proteins. Thanks for watching.